Let's try to understand elementary dynamics part 1. Well, dear students, let's try to understand the elementary dynamics. There are a lot to learn under elementary dynamics. We'll try to learn few of the things from the elementary dynamics. Okay. To begin with, let's define kinematics. It is a branch of mechanics that studies the motion of a body or a system of body without consideration given to its mass or the forces acting on it. Whereas that is cause of motion is not considered. Okay, so it is also a motion of the body or system of body where the consideration of mass is not given. So body is moving, there's no doubt about it. Okay, body is moving this way, this way, this way. Wherever you want the body will move, or a group of bodies may be moving together. Okay, but there also you have to see that. Okay, where but the consideration for the mass of the body or the force acting was not given. Okay, that is the only difference here. Okay, let's try to understand another definition, which is dynamics. It is a branch of mechanics that studies the motion of the body or a system of body where the cause of motion is considered. Okay, here how the motion is taking place, what is the cause of this motion, this is very important here. That is the cause of motion is important. Okay, let's try to take another definition, that's called displacement. Displacement is the shortest distances from initial to the final position of point P. Suppose if I take point P, many times student has the difficulty. If this is my point P, then suppose the distance from this point P, okay, distance from this point P, okay, let's go. Okay, let's go to try to understand distance between a point from this end to this. Let's take as 1 meter. Say this point, you can take point A, P. Now the body move from point P to end this point, extreme point. So it is a 1 meter. Okay, say 1 meter. Now, and the distance is also 1 meter. Now body will come back to same position again. What do you expect? What is the distance? Obviously distance is 2 meter. Okay, but what is displacement? That's a big question. If you see the displacement, okay, the body has reached back to the same position again. You can see same position again. So displacement is 0. The body is no more displaced. Okay, but distance traveled is how much? 2 meter. That is how we can understand distance difference between the displacement and the distance. Many times have this confusion in the mind of the student. That's how I put here. Okay, so displacement of vector quantity. Let's go ahead. Well, if you see there, the first definition you can see velocity. As you know that velocity can be defined as a rate of change of displacement with respect to time. So consider this fact, we can write, okay, that velocity can be given by displacement upon time. Okay. Similarly we can define what is accelerations. Okay, acceleration is defined rate of change of velocity with respect to time. It is a vector quantity, is SI unit meter per second square. Okay, so your acceleration becomes, okay, your acceleration becomes nothing but it is the velocity upon time, or you can say rate of change of velocity. Okay, there's a way of understanding. Thus we go ahead, we say since as we said that the velocity, okay, since the velocity is defined as, okay, velocity is displacement upon time, so we get this, what is that, velocity is equal to displacement upon time. And if you go ahead, okay, you can write this as acceleration as v minus u upon t. What is v? V is the initial velocity, v is the final velocity. Here v is the initial velocity and u is the initial velocity, and the t is time. The time, total time taken, can be written as t. Okay, that become your what is called as accelerations. Okay, you can remember these three definitions. Let's go ahead. Let's try to understand something more about your element dynamics. The first thing to describe here is the uniform motion. What is uniform motion? The motion of an object is said to be uniform if it moves equal distances. Okay, that's very important point here. If it moves towards equal distances in equal interval of time, that means its motion is uniform. So it's moving in uniform velocity because it's moving is covering equal distance in equal time, right? That's very important. Okay, that's called your uniform motion. So we are going to prove this ahead. Okay, those formulas, kinematic formula that moves uniform motion, this 3-1, we'll try to prove it and try to understand how to. These are true, formulas are true. We only need to prove and show is it true. Okay, let's use the initial velocity is the acceleration, t is the time, and s is the displacement. Okay. Okay, thank you.